Jai Janendra, Namaste and welcome to my channel. Today we are going to solve the 89th question of the problem solving series and the 14th question of the topic linked list. The difficulty level for this question is hard and this question has been asked in Amazon, Microsoft, Flipkart, Paytm, Qualcomm and Goldman Sachs and many other companies. Flattening a linked list. So we are given a linked list and this time its name is node here in this example and it has two pointers. One is the next pointer and one is the bottom pointer. You can see here. Okay, and we are asked to flatten this linked list. That means if you look at this example, this 5 has this next pointer and a bottom pointer, and it's also given that this bottom pointers, this sub list is actually in sorted order, right? So you can see 5, 7, 8, 30, 10, 20, 19, 22, 50 and this 28, 35, 40, 50. All these pointers which are in bottom, they are sorted. Now you need to flatten this linked list and return the linked list such that all of them are in sorted order. What does this mean? That in this case you will see this linked list will contain all the elements with only its bottom pointers, but all this but the next pointer of all these elements should be null, but the bottom pointers elements should have all these numbers and it should be in sorted order. So it would be like this: 5, 7, 8, 10, then 19, then since I don't have space, so I am going this side. 19, then what should come? 20, 22, then what is the next big number? 28, 28, okay. So I'll write like this. I'll write like this. Assume that this is in the bottom direction, okay. 5, 7, 8, 10, 10, 19, 20, 20 will be going to 22, 28, 30, 35, 40 and then 45, okay. So we should be returning this in a single, we'll flatten this to a single linked list and we will only consider bottom as the having the exact node with data and we'll make the next of all the nodes empty or null, okay. So this we should return. Now how do we do this? Here you can see this 5, 10, 19, 28 is also in sorted order, but this is not necessary. In this example you can see this 3, 2, 1, 4, 5 is not in sorted order, right? It's given that only this has to be sorted. So one thing to notice. So for this example, what would be our answer? It would be like 1 pointing to 2, pointing to 3, pointing to 4, pointing to 5, pointing to 7, pointing to 9, pointing to 10, pointing to 11, pointing to 12. Did we miss anything? Yes. 6, 7, 8 and this 9. And yeah, so this would be our answer. Now how do we do this? So what can you think of right now? How we'll solve this? So here you can observe one thing, that this is a sorted thing, okay. This bottom thing is a sorted thing. If we take a new linked list and keep on traversing this linked list from here to here, okay. So 5, 7, 8, 30, we have a new pointer here, okay. We have taken a new so here it's given root, so we take a suppose root 2, okay, and then create a new node pointing to 0 and then we start traversing this linked list. So our pointer is here and we go this direction, okay. So we store all the elements, say 5, 7, 8, 30. We store this also, then we would go, once this is over, then we go here and we store 10, 20. Okay, we are storing, okay, store it, instead of storing it in a linked list, let's store it in array and let it be unsorted. Okay, in this case, this is not sorted, right? 30, 10, 20. So this is not sorted. So we'll take an array. Let's take all the elements. This is our brute force solution, which you can think. 19, 22, 50, we are here, and then we came back again here. 28, 35, 40, 45. All these numbers are in the array. We have got the elements. Now we'll sort it. Okay. So after sorting it, we will get it in a sorted order, and then we'll create a linked list and we'll traverse this array and we'll store it, and then we'll return that new linked list which has only bottom like this. We'll get our answer. What would be the time complexity? Since we are traversing all of them, so it will be n into m. Okay, and then we are storing it in array and sorting it, so it would be n log n into m log n into m, and again we are inserting it into the array, so it would be order of n into m plus order of log n into m, right? So it would be too much, and also the space complexity would also be n into m max. So how do we optimize this now? So in the beginning I said that this this vertical linked list is in sorted order, right? So now can we use this property? If we use this property, so this or n log n, can we exclude it and make it in time complexity n into m? Also one thing, we already have a linked list. Instead of creating a new linked list, can we do it in place? If we can do it, how can we do it? I've solved a question merge two sorted list, where we were given two lists that were sorted, and then we merged it and we returned one linked list, right? Can we use the same if for this and this linked list, if we consider them these two? If we use the same logic of merge two sorted list here and here, we'll get a new sorted list. Once we have the new sorted list, which has all this in like vertical one list, can we use it for that big and this number to get a new sorted list, right? So once we merge, say this is A linked list and this is B linked list. If we merge them, we make a new linked list, say C, and this is D. So C and D again can be merged and we'll have say E. So there is a E linked list which has all these numbers that are in sorted order, and then we have this A. So A and E again can be sorted, and a new result of linked list F can be written, and we'll get this what we want. Can it be done? Yes, it can be done. So in that case, our time complexity would reduce to order of n into m, right? So let's code that the optimized approach directly. What would be our base case? The base case would be if say we need to go at the end, right? So at the end, this end results will come over here. So if we see that the root is null itself, right? When we get that the root is null, or the roots, so if root is null or the roots next is null, right? Then we'll be returning root. Say for example, if only there was this one linked list, 3, 7, 8, okay, then what would have happened? We would have written this single linked list. Or if there was no elements, so we would have written null. So in that case, we can say that if root equal to null, or root next equal to null, right? Then we return root, right? Or now, so this is our base case, right? When we will be writing this, since this is a recursive function, we already discussed. So this is our base case. So first we have to go here to find out its sorted order, right? To merging the two sorted lists. So we have to go and check, okay, for if what would be the value for this one. So so if we are here, say here in this linked list, so we need to find out what is the answer of this merge, these two merge. So its next, tense next would be pointing to the merged value of these two lists. So whenever we are suppose here, then it would be its 5's next would be the merged value for this one and this one, right? So in that way, what would be our function relation between the a recursive function and the function that roots next is equal to flatten of roots next, right? So this its next would call flatten of this next. So for this it will call this, and for this one it will call this one, right? So now when we are at 20, this is 28. So when we are here, so its next would be actually null. So it would be returning root, it would be returning this 28, same thing. Now when we are here and we are going to return its next value, right? Since this has only one value, here we are there, so it returns roots next here. You need to understand this. Now this is single linked list. So for single linked list we will return root. So 19 next will be pointing to this, and then we are 19 next one is pointing to this, and then its value we don't have, so it has this linked list and it has this linked list. So now if we merge these two, then whatever is the value, if we return that, we have not returned it anything yet, right? For this one we have returned it, but for this one, when this calls this one, here now two pointers are there, this pointer and this pointer. We have not returned anything, so we need to return something so that this gets it. And what does this want? This linked list want? This wants the merge value for this list. So here we will call root is equal to merge function of root and root next. This is the logic, right? Now we will merge the two sorted lists that we have done before also in one question. So now we will merge this and then we will return root, right? This merged values, and now this merged value will go here and this will be getting this. Now for these two, it will be called again this merge function. Okay, now when we get this big pointer and this pointer, and that way we'll get the whole list. Now we need to code this merge function. We have already done it before, so I don't remember the exact question, but you can see the playlist. It was done in some, I think 84, 85 some question number. We did this merge sorted list. Okay, so let's do it for fast. Okay, so node strict merge node strict A, node strict B. Okay, so we have these two pointers, and now how do we merge it? We take a new pointer, say node strict temp, and assign it as new node and 0. Okay, so 0 means we'll have this data as 0, and this next and bottom will be pointing to null. Okay, the constructor would be done for this. So we have this, and now what we do, we assign temp1 is equal to temp. Okay, because we will move temp from A and B, so that we can give the temps one's next value, because temps 1 next will be pointing to this A and B's values. Okay, so now we are here. So what we do now, we check while A not equal to null and B not equal to null. Okay, when both are not equal to null, we can make the comparison, right? So if A bottom is less than B bottom, okay, if A value, not A bottom, sorry, if A data is less than B data, okay, if A data 19 is less than 28, right? So in that case, what will happen? We'll point temp next to A, and then we'll move temp is equal to temp next, and then we will move A is equal to A next, right? So that now 19 is part of our temp, and then temp was at 0, now temp comes at 19, and A moves at 22, B is still at 28. And this one will again, 22 is less than 28, so again in this temp will be moved to 22, and A will be moved to 50. And now else condition, when B data is actually less than A data, then what will happen? Temp next will be pointing to B, temp will be temp next. You already know this, then you can skip and try to solve the question yourself. because we are just coding this merge function. Temp equal to temp next, and then b is equal to b next, right? You're done. If so, this is done. If a not equal to null, then what will happen? We'll return temp next is equal to a, so that we can take the whole values of a. If b not equal to null after this function, this while function, once it gets over, okay, if b not equal to null, then our temp next would go and point to all the b pointers values, right? And at the end, what will return? We will return temp1 next, okay? And in this way, it will be done in order n into n. Okay, I hope that explanation is clear. The link to the question is given in the description. Please try it yourself and then surely come to my code walkthrough section. Here is the code walkthrough of the 89th question of the problem solving series and the 14th question of the topic linked list in the Gigs for Gigs platform. Flattening a linked list. You can see this question has been asked in these companies, and we have already discussed the examples. So directly let's look at the code. So here we have, this is the base condition as we have discussed, and this is the recursive function that we have called here, and then we have this root to merge two lists, and then once it's merged we return this root, okay? And this is the merge function. You can check the code, okay? Temp new node equal to 0 and result is equal to temp, and we return result, okay, not next, okay? We don't return result next, we return result bottom, because it's given that we need to return the bottom list. So I think I have returned the next thing, but we'll actually not return the next thing, okay? This is next, okay, but here our comparison has to be with the bottom, okay? You check the code again here. This merge to list, up to this much it's fine, it's return root next, but here when we return, we compare this data. So we move, instead of temp next, temp bottom would be moved to a, okay, because we are sorting this two, okay? Next nothing is there, so this will be temp bottom would be pointing to a, temp would be pointing to temp bottom, and a would be pointing to a bottom, okay? That was my mistake. I didn't I forgot that it's bottom, okay? So that's why this code walkthrough section is very important. Here similarly, if a data is less than b data, okay, if b data is yes, so here if when a will be moved to 50 and if it's 28, so here we will move temp bottom equal to b, okay? So whatever the value is there for the temp bottom would be pointing to this, okay? After 22, when it is, because a is in 50, temp would be in 22, so temp's bottom would be pointing to 28 then, okay, instead of 50. And then this would be null, and then will this 28 be pointing to 50. So we'll have this 19, 22, 28, 50 as a single pointer with its bottom values, and then that would be compared with the 10 again, okay? So this is the change, okay? This very simple thing that I missed, okay? So yeah, let's submit this code and see if this works. Okay, so all the test cases have passed. Have you understood the solutions? See you also in the next video, where I'll be explaining the last question of the topic English, the 90th question and the 15th question of the 90th question of the problem solving series, and the 15th question of the topic English.